A closed system changes from one state to another state by exchanging energy with its surroundings. During the change of the state functions of the system also change. There are two forms of energy exchange, that is, work and heat. We can see later, work and heat are not state functions, but path functions. Path functions are the quantities depending on the path of the change. Work is the energy transferred to, or from the system through the change of ordered motion of particles. The most typical work in thermodynamics is pressure-volume work, or PV work. Suppose there is a gas cylinder with a cross-section area A and length L. The pressure of the gas is P. A piston can move to change the volume of the gas. When it moves, work is done to the gas. The motion of the piston changes the way all the particles move, so it's an ordered change of motion. PV work is calculated using classical physics. Work is the product of force and distance. The force applied to the gas by the piston is the product of the pressure and the area of the piston. The product of the area and distance of piston motion is the change of volume. Symbol D is used for the infinitesimal change of state functions. Pay attention, first, we suppose the motion of piston is small, so that the pressure can be considered as a constant. Second, if the motion and force have the same direction, the work is positive, but the volume decreases. Thus, we have the formula for PV work like this. Symbol delta is used for the infinitesimal change of path functions. Heat is energy transferred to, or from the system through disordered motion of particles. When the system receives heat, the random motion of the particles inside it becomes more violent. The equivalency of heat and work was proved by a series of experiments. The most famous one is James Prescott-Joule's experiment. In Joule's experiment, gravity does the mechanical work on a falling weight. A paddle wheel was driven by the falling weight in an isolated barrel of water. The temperature of the water increases. When the water stopped swirling, the temperature increase is proportional to the work done to the weight. So, doing work to a system is equivalent to heating it. In Joule's experiment, the motion of water caused by the spinning paddle wheel gradually converts to disordered motion of water molecules due to the viscosity of water. Internal energy is the energy of the entire system, excluding the mechanical energies of the system as a whole. For example, the gravitational potential energy of the whole system is excluded from the internal energy. The kinetic energy of the whole system is also excluded. Internal energy is a state function. In chemistry, we don't consider the energy caused by nuclear interaction as well, that is, the nuclear energy. In chemistry, the internal energy includes chemical energy stored in chemical bonds, and kinetic and potential energy of the atoms. For example, the vibration of atoms in molecules store potential and kinetic energy. The rotation and translation of molecules store kinetic energy. The interactions between molecules stores potential energy. The first law of thermodynamics states that the change of internal energy is the sum of heat and work. The first law of thermodynamics is a version of law of conservation of energy. For a closed system, the energy change is equal to the net energy flow into it. For example, if a system receives 150 joules heat from its surroundings, and it does 10 joules work to the surroundings, the change of its internal energy is 140 joules. If the change is infinitesimal, the first law of thermodynamics can be written in infinitesimal form. If there is no work other than PV work, it is in the following form.